This video will show you how to do vertical stretching and shrinking. So we need to take this function, f of x equals x cubed, and derive this transformation. Well, before we can ever get to the transformation, we have to know what f of x equals x cubed looks like. Keep talking about the fact that you need to memorize. X cubed we know is this little squiggly like this. To know exactly where it goes through, here's a couple points. Just chose these numbers, plug them in and cube them, and we get these, -1, -1, 0, 0, 1, 1. But you got to be careful. That looks like a line, and we know x cubed is not a line. What it does is squiggle right through here, which I'll just kind of make an approximation and show you a better graph on the next screen. That's our graph of y equals x cubed. For purposes of the video, here's a better looking one right here, neatly drawn on the graph. And there's our 3 points that came from our t-chart. What we want to do is this 1/2 times x cubed. Remember what this is. F of x equals x cubed. That means y equals x cubed. So over here I can think about x cubed being y. So all this is telling me to do is to do half of my y value. So I can take the values that are on the graph and just take half of the y value. That point right there is a y value of -1. Half of that is -1/2. Half of 0 is 0. Half of +1 is a half. Knowing that this has to approximate the same shape, I know that this is going to squiggle, but just squiggle a little wider. And I can't quite do it right with this tool, but you get the idea there. Now, if you can't do it straight from the graph, if you have trouble looking at those points, then look at the t-chart. Take your t-chart values right here. This is an adjustment to the y value. That says these x values should stay exactly the same. Half of -1 is -1/2. Half of 0 is 0. Half of +1 is a half. So I'm just going to take these points and actually plot them on this graph. -1, -1/2 is right there. That's the same point we had, but we're getting it a different way. 0, 0. And this is the point over 1 up a half. And then I'm going to try to draw this little curve again. And it's not too bad, but that's how it's going to squiggle through there. Now, same idea here. This is just not one of the curves. This will be easier for me to draw because it's angled here. This is just some little f of x that I have drawn, and we want to do 2 f of x. Same thing. I'm going to do it first from the graph standpoint and then go back and look at the t-chart values. I'm going to take each of the y values. I'm taking these little corner points there, and I'm going to double each of the y values. So that's a y value of 0. It's going to stay there. That's a y value of 1. It's going to go up to 2. That's a y value of 0. If I double 0, it stays 0. That's a y value of 1. If I double 1, it's 2. So that is, oops, that's there, down, and back up. That's a pretty lousy drawing. It should be more angles, but I've told you before I can't draw these things. But let's take this away and look at this from the t-chart standpoint. The t-chart tells me I need to make adjustments only on the y column. So all of these x values right down the column are going to stay what they were. Double each of these. 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. And then I'm going to graph those on this graph. -2, 0 is right there. 0, 2 is right there. 2, 0, and over 4 up 2. Let's see if I can draw this a little better. There's my line, a line, and there's a line. So that looks pretty good there. In red is my solution. Now you might be saying, how do I know that this is a vertical situation? Well, look where the 2 is. The 2 is outside of the f of x. If it were inside with the x, then I'd know it's an x thing. Because it's outside of the f of x, then I know it's going to happen to y. And since it's happening to y, it's doing exactly what it says. It says 2 times y, so that's what I did. I didn't do anything to the x values. So here's our rule. If this c value in this expression right there is greater than 1, then the graph of y equals f of x is vertically stretched by multiplying each of its y coordinates by c. On the other hand, if c is a value between 0 and 1, meaning a fraction, then the graph is the graph of y equals f of x vertically shrunk by multiplying each of its y coordinates by c. Go back and look at this. This is the situation where C was a whole number, and look what happened. Our graph got stretched out. I don't know if you have ever done any graphs of sine and cosine, but it's the same kind of amplitude change. We are just grabbing hold of this and stretching it out. This one got flattened out. Instead of being multiplied by 2, it got multiplied by a half, so each of the y values were half as high as they were before. So, does it make any difference if this number is a negative? No, we're still multiplying by -2. Now this original function is f of x equals x squared, so I have to have an idea of what my original parabola looks like. We know this is going to be a curve, but I got to get it in the right place. Here are my regular t-chart values for x squared. -2 up 4, which is about there. -1, 1, 0, 0, over 1 up 1, and over 2 up 4. Now if I try to actually draw this curve, it's going to be a mess, so I have it graphed out over here using the graphing calculator. But there are my same points that I had from my t-chart. This right here tells me to multiply each of those points by -2, each of the y values by -2. So this is a y value of 4. If I multiply it by -2, it's way down here at -8, which it's way off the screen. This was a y value of 1. If I multiply it by -2, I get it down here at -2. This was a y value of 0, so 2 times 0 stays 0. -2 times 1 is -2. And -2 times 4 is way down here at -8. So my graph, my curve, should look, well, that's pretty horrible, but you can approximate it from where those dots were. If you don't want to get those values straight off the graph, look at your t-chart. We know we're supposed to multiply -2 times the existing y value. So I'm taking each of these values and multiply by -2. 4 times -2 makes -8. 1 times -2 makes -2. 0 times -2 is 0. 1 times -2 is -2. 4 times -2 is -8. And those are these points that I've got graphed. I didn't do a good job on the curve, but my points are in the right place. This is the ordered pair, -2, -8. This ordered pair, -1, -2. 0, 0. 1, -2. 2, -8. And those are exactly those points right there. So use the t-chart if you think that will help you. All right, horizontal stretching and shrinking. If you remember what the situation was on a horizontal shift, two things. It's a horizontal shift if it's an x thing, and the reason I know these are x things, look where the c is in this expression, cx. That's inside with the x. Therefore, I know it's an x thing. Also, remember when it's an x thing, we do the opposite of what you'd expect. So this says if c is greater than 1, the graph of y equals f of cx is the graph of f of x horizontally shrunk by dividing each by c. In other words, this is going to be like f of 2x. And what I'm going to do to the x values is not double them. I'm going to take half of them. I'm going to divide by 2. If your c is between 0 and 1, then your graph is going to be stretched by dividing each of the x coordinates by c. Now, if c is between 0 and 1, that means it's a fraction, like maybe a half. So instead of thinking of dividing by the fraction, think of multiplying by the reciprocal, because that's what you do when you divide fractions. So it's an x thing, so we do the opposite of what you'd expect. The best kind of graphs for me to use for you to learn this is one of these just kind of weird ones that I draw the picture separately. So here's a picture I just happened to draw. Here are the ordered pairs that go with that. Then I'm going to do what this says here. This is f of 2x. So I know I need to divide x by 2. It's an x thing because that number's inside the parentheses with x, and because it's an x thing, I do the opposite. It looks like 2 times x, but I actually divide by 2. So I'm going to take all of those values right there and divide them by 2. -4 divided by 2 is -2. -2 divided by 2 is -1. 0 divided by 2 is 0, and 2 divided by 2 is 1. All of the y values are going to stay the same. 0, 2, 1, 2. Let's plot these points and connect them and let you see what the graph looks like now. -2, 0 is here. -1, 2 is there. 0, 1 stays there. And over 1 up 2 goes there. And if I connect these, now can you see that that blue graph covered a lot more ground? It went all the way from -4 to 2. Look how much ground my red one. My red one only covers from -2 to 1. If you think about this being a distance, it went a distance of -4 to 2. It went a distance of 6 units, spread out across 6 units. Look at my red. It's only spread out from -2 to 1, which is a distance of 3 units, exactly half of the distance that the blue covered. Now another little funky drawing here. Here's my original values that are in the t-chart, and this says f of 1/2 x. It's inside with the x, therefore it's an x thing, and we do the opposite. What the rule said is divide by 1/2. I say, since that's a fraction, instead of dividing by a half, you want to multiply by the reciprocal. The reciprocal of 1/2 is 2, and we're multiplying the x value because this is an x thing. So I'm going to take all of these numbers in the t-chart and double them. -4, 0, 2, 6. All of the corresponding y values stay what they were. We are not making a y adjustment. Let's graph these points. -4, -1, 0, 0, 2, 2, and way over here it's 6, 0, which I didn't leave enough room there. So now let me connect these dots. There, there, and then like way over here. So notice my blue covered ground from -2 to 3, a distance of 5 units. My red is going all the way from -4 out to +6, which is a distance of 10 units. So it's doing the opposite of what you'd expect. This 1/2 is actually taking your graph and stretching it out so that it's double the width of what it used to be. This one, it condensed it. It was able shrinking. It used to cover 6 units, now it's just covering 3 units.